Okay, today's topic is related rates. And before anything, I would like to let you know that this topic is in the book. It's in chapter 3, section 3.8. So if you want more reference, if you want more examples, explanations, you can always look up in the book and also practice problems in this topic as well. So related rates, it's about applications of derivative. Application of derivative f prime of x. So basically we are going to make use of the derivatives that by now should be not too difficult for us to find with all those rules and techniques, and we want to use them to solve practical problems. And before we go into the details on how to solve problems on related rates, let's revise about the things that we learned in this class, the three concepts of derivatives. Three concepts of derivative f prime of x. When I talk about concepts, it's about interpretation, it's about how you see it, it's about how you add meaning to derivative instead of using definition. So we talk about three concepts of f prime x. The first one that we saw in this class is about how we look at this f prime x as the slope of the graph fx. Slope of graph fx. So basically we have this, let's say that we have this graph of fx, and then we are interested in a particular point, let's say this point, and we want to find the derivative at this point. One way to look at this is to look at this point really closely, and we are going to see a small section of straight line. See right here, really small, and the slope of that small straight line is is how you see the derivative in this graph. Some of you might say that this is not so obvious. So another way to look at the derivative is to look at this as the slope of tangent line. So instead of using the small section on the graph to define derivative, we can use this straight line, red straight line, linear line that touches the graph at exact point that we are interested in. And the slope of this red line can be interpreted as the derivative of at the point that we are interested in, and the same point right here. So that is the slope of the tangent line. And we also talk about the third way of how we look at derivative. The third way that we look at is the rate of change. At this point, I would like you to see the difference between 1, 2, and 3. 1, 2 is similar. It's about the slope of a shape, whether it be lines or a triangle. But number 3, rate of change, it's quite different. It's not the same as 1 or 2, because 1 or 2 we look at something geometrically by using shapes. But when it comes to rate of change, we add meaning to it. We want to know how changes occur. For example, instead of looking at the slope of something, we want to know how f or y changes when x changes. Let's see. I want you to see this main difference, how you interpret the meaning. So let's say that x changes, and I want to know what happens to this function value. What is the change of that? And that is how we look at the rate of change and how we use this concept to define derivative. And in this topic, related rates, you see the word rate. So which means that in this topic, it's going to use the third concept of derivative that we have seen so far. We are going to use this. In this topic, it's going to be quite similar and related to one another. So that's about it for introduction to related rates. And before anything, I would like to talk about the concepts of related rates, to talk about the heart of this. And I just want to use this one slide to talk about the main concept of this thing. Related rates. I would like to start with the word rate. Rate. What is it? Rate. I'm sure that you have seen this word so many times, but when it comes to this calculus class, rate, let's define it. It's about how a quantity when I say quantity, it can be anything. So let's say that this quantity is a variable x, or you can say y, it can be anything. How a quantity changes with respect to time. It's about how something, certain quantity, changes when time passes. Once again, this quantity can be just about anything you want. For example, volume of water in a tank, volume. Or it can be area of a surface of the balloon, or anything area of this certain shape that you want to study. It can be distance between two objects, distance between an airplane and an observer on the ground. It can be velocity, how velocity changes over time. And it can be anything else, temperature, pressure, anything you name it, anything that you want to study. So we want to know how these values, volume, area, distance, velocity, changes over time. So let's say we want to know how this variable x changes over time. We want to know how this changes when time passes. So this is just how we see this word rate. But when we look at the certain moment, at a certain point, we are going to look at this as dx by dt. Okay? Let me change this a little bit. The x by dt. This is also change, but it's instantaneous change. Same thing. This is a long-term rate, and this is just at that moment, instantaneous. Instantaneous change of x with respect to t. I want you to keep in mind that when it comes to rate, it's not always about time. But at this point, let's just focus on time, because most of the things you are going to see is about how it changes with respect to time. So rate, now we see the connection from rates to dx by dt. So we can see that when it comes to rates, it's dx by dt, and you can make x anything you want. And this is basically the first derivative. Okay, rate, derivative. Now, related rates, what does that mean? It means that it's going to be about rates, and they are related to one another. So, related rates is about relationship between let me change that. Relationship between rates. Just like the name, related rates, relationship between rates. But before that, we say that rate is equivalent to first derivative. So basically, this can be interpreted as relationship between derivative. And we talk about first order, first derivative, which means that we are going to have many kinds of derivatives in our problems, and we want to find the relationships between them. And when it comes to math, relationships can be explained by using equations. So in the end of this, it's all about equation containing several or many derivative. That's it. That's the heart of related rates. Yes, it's about relationship between rates, but when it comes to math, it's an equations. And in the equations, we have derivatives. And we talk about first order derivatives. So this is the heart of this problem. Once you find this equation containing derivatives and you solve it, you're done. So I want you to put a star to this. In the end, we solve this, but we start with the concept in the beginning. Okay?